In this skill, we're trying to identify the acid, base, conjugate acid, and conjugate base in a reaction. When an acid loses H+, it becomes its conjugate base. When a base gains H+, it becomes its conjugate acid. For example, let's say we had an acid HX that forms H+ and X-. HX would be our acid. Then it loses the H and we're left with just X. So the X-, that would be our conjugate base. Similarly, for a base, let's say we had a base XH3 and it dissociates in water to give XH4+, so it's gained an H+. XH3 would be the base and XH4+ would be the conjugate acid. The reason that the acid forms a conjugate base is because this thing here, if we were to do the reaction backwards, it would be gaining an H. And anything that gains an H is a base. So that's the conjugate base of the acid. And the same thing here with the base. We call this the conjugate acid because it has that extra H+. If the reaction were to go backwards, that would be losing an H+ or donating an H+, which would make it an acid. So that's why it's called the conjugate acid of this base. Okay, so let's give this question a go. In this question, we have the hydroxide ion, OH-, reacting with the ammonium ion, NH4+, according to the following equation. OH- plus NH4+ gives NH3 and H2O. So first we need to figure out what's our acid and what's our base. So let's look at OH- first. We start with OH-, we end up with H2O. So to go from OH- to H2O, we're gaining H+. So if OH- is gaining H+, that must mean it's a base, because remember, acids donate H+, bases gain or accept H+. So that means that OH- must be the base. Now, according to our definition down here, when a base gains H+, it becomes its conjugate acid. So that means H2O is the conjugate acid of OH-. That makes sense because if we went backwards, if we started with H2O, we'd have to lose an H+ to get to OH-. Donating an H+ makes you an acid, which is why H2O is called the conjugate acid in this reaction. What about NH4+? It becomes NH3. To get from being NH4+ to NH3, you need to lose H+. Losing or donating H+, that makes you an acid. So NH4+ is acting as an acid in this reaction. That means, according to our definition, that NH3 must be the conjugate base. And that makes sense because NH3, to go backwards to form NH4+, would need to gain or accept H+. And gaining or accepting H+ is something that bases do. So that's why NH3 is called the conjugate base. So in this skill, all you need to do for each question is identify what's your acid and your base on the left-hand side of your reaction by determining whether they're losing or gaining H+. If you gain H+, that makes you a base. If you lose H+, that makes you an acid. The partner in the products that acid or base becomes, those are our conjugate bases and conjugate acids.